Hello and welcome to this repair tutorial, and today we're going to look at a Marantz. Model number is PM5005. So in terms of general specifications, you're looking at an RMS power output power, frequency range of 20 Hz to 20 kHz, and this is simultaneous drive of both channels, 45 watts times 2 ohm speakers, and that will actually increase if you connect 4 ohm speaker load to 50 watts. And then total harmonic distortion over the frequency range of 20 Hz to 20 kHz, you're looking at 0.05%. And then output bandwidth with an 8 ohm speaker load is 0.06%, and that's frequency range of 10 Hz to 30 kHz. And then frequency response for your CD with 1 watt power at 8 ohms, frequency range of 10 Hz to 50 kHz, plus 0 dB to minus 1 dB, and then the dumping factor is 8 ohm load, 20 Hz to 20 kilohertz, and then input sensitivity and impedance, phono input, millivoltage input is 2.2 millivolts, and this is where you can connect a moving magnet type cartridge turntable directly, no requirement for an equalizer or preamplifier. And then for your CD tuner network record 1 and record 2, then maximum input voltage would be 200 millivolts with an input impedance of 20 kiloohms. And then overall weight for the amplifier comes in at 6.7 kilograms. And then dimensions, height is 105, width is 440, and depth is 370 mil. Now these amplifiers have sold in good numbers, and you also have the 6000 range as well as the 4000 range and 5000 range. Now, when this amplifier came into the workshop, it's actually from a customer who contacted me via the YouTube channel, which you're listening to now. Thank you. And what the customer advised was that they had a number of issues which had sort of really manifested themselves. You know, 1 minute the amplifier was working fine, and then all of a sudden it developed a particular fault. Now, the issue, or the main issue, was if you had different inputs connected to the amp, what would happen is you'd have like a crosstalk between channels. So my example here would be maybe you had, say, the CD input connected, and you also had an input source maybe to the tuner. What you would hear then is if you selected tuner, then you would get bleed through them from the CD input, even though it wasn't selected. But the customer also reported another issue as well, where they said that if they first powered up the amplifier, then there would be no output at all. And then if you operated the amplifier power button a number of times, in some cases you could get the amplifier to start up, and then you could get audio. And then the third issue was that this amplifier supports an auto standby mode, which means that if you have no inputs connected, so there's no signal source coming into the amplifier, because it's powered up and you don't touch any of the front facial buttons or the remote, what should happen is after 30 seconds the amplifier should automatically shut down to conserve power and go into a standby mode, and the customer reported that was not happening. So really, how do you sort of go about to sort of investigate this? Well, the first thing was, and what I'm showing you now, is that once the front or the top cover plate was removed, what you can see is this very heavy layer of dust. And this is normal, right? So you're going to see this on all amplifiers if you're looking to service or repair them. For the Marantz amplifier, you have this grill on the top, which of course is required because when the amplifier is running, like any electronics, it will emit heat from the power dissipation from the different components there. But this amplifier, has been kept in a very good environment. And what I'm referring to is sometimes if the environment is maybe damp, or there could be moisture in the air, what you can find is that this dust sticks to the circuit board. It makes it very difficult in some cases to remove, but very straightforward here because the dust is completely dry, and all it required was a compressed air hose just to remove that, and just a small brush just to brush in between the components. And then once that was done, of course, I could then start to undertake the repair work. Well, normally when you get crosstalk on these amplifiers, the first thing that you're going to look at, and I've sort of highlighted it now with this photograph, is the input selection IC. And on this photograph, what I've done is I've drawn a number of circles around the different components so you can see them. And the first thing you can see just on the towards the input RCA sockets, this is the dedicated input selection IC, and that's an LC78212. Now, you can get failures of this IC if, for example, the user is connected maybe to the CD input but doesn't fully disconnect that input before maybe transferring it to another input. So maybe the right input is connected to the CD right, but then the left was unplugged and then plugged maybe into the tuner left. And that can cause the imbalance, which will destroy the IC. So that's the first sort of point of call that you look for this type of fault. And what you have is a multi-pin connector, which is near to the large power supply smoothing capacitors, and you'll have the left and right channel and then the ground. So what I use is just an audio signal tracer, and I'm just connecting one or the negative lead of the signal tracer onto the negative terminal for the speakers, and then I just go on to that multi-pin socket. And what I'm not hearing at all is any kind of audio. So you think, well, okay, maybe there is an issue with the IC. So you double check just to make sure your simulation signal is coming in, and no issue there. But normally when these ICs also fail, if you just sort of place your finger just on the top of the IC, what you can feel is some heat dissipation, and there was nothing going on here. So rather than sort of just jump in and then think, okay, I'm just going to remove the IC and then do a substitution, this IC is powered from a plus and minus 15 volt supply, and that's something you need to check before you even consider removing the IC. And this would be common with any kind of fault find. You're just going to verify that your DC power supply voltages are fine and that there's no issue with them. So the next thing that I'm showing you is an extract from the service manual, and what you can see here is the DC power, and this is what we refer to as the block diagram. And when I was doing the voltage measurements, the ICs that I'm interested in is U8101 and then also U8102, and these are the plus and minus 15 volt regulators, and you can see that it says that it's for the preamp and then tone amplifier. Now the issue here was that when you measured the output from the KIA 7815 positive voltage regulator, and again what I'm now showing you is how you do that measurement. So sometimes it's a little bit difficult to sort of get your multimeter in there. It could be very, very low profile like in this case. So what I've used is just a hook clip, and then I've connected that to the output terminal of the regulator, and then the negative terminal then is just going back to the common negative onto the speaker. And then what you can see in the next photograph is the multimeter, and what the multimeter is showing you is that the DC output from the IC is 3.224 volts, and that's a problem. Now these KIA regulators, and there's 4 of them in this Marantz amplifier, there is one which is 12 volts, which is used to power different parts of the circuit, but including the speaker protection relays. You have the 5 volt source, which of course is for the microcontroller, and as I said, these 2 plus and minus 15 volt regulators. Now they are made by the Korean Radio Corporation, and this is a very, very well known and respected brand. But I have seen over many years failures of this type of voltage regulator, and I've seen it in Pioneer amplifiers, I've seen it in Marantz and other brands. And rather than just replace the single regulator, because I've had the same issue here where the negative 15 volt regulator has failed, what I do is I just replace them all. Now to gain access to the amplifier circuit board, it is very easy. So you just need to just turn it around and then get access to the back panel. Remove the multiple screws, and these bronze type coloured screws, which is well known with all Marantz amplifiers. And then what you'll have is just some standard stainless steel metal screws just on the bottom. And then once you do that, you can just remove the back panel. You can actually unplug it if you wish from the power supply startup board. And then it's a case of just removing approximately 5 fixing screws, and then you then disconnect the multi-pin connectors. There's also on the right hand side, when you look from the rear, the over thermal protection IC, and you can just unscrew that, and then you'll be able to extract the amp board. and then just move the chassis to one side, and that's what I'm showing here. So what you can see now is the circuit board on the bench, and this makes it very easy to work on. And then what I'm also showing you here next is that power supply section, and what you can see are 4 voltage regulators. The 12 volt regulator is mounted onto a small heatsink, but the 5 volt regulator is just the one just almost out of sight, just on the edge of the board, and then the plus or minus 15 volt regulators are the ones which are directly towards the front part of this photograph. So what I do is I replace all of them, and the reason for that is, and I've often mentioned it, that you need to create or to put longevity into any repair that you undertake. And because I know from experience that these ICs or these voltage regulators do fail, then there would be little point just to replace the faulty one and not, do any additional work. So the next thing that I'm showing you is 4 brand new regulators, and these are ST Micro devices, and then I just do a block change out. I'm not interested to do any further measurement on any of the other voltage regulators, and once those are block changed, then the next part of course is just to refit the main circuit board, and then I also secure in place the back panel. Now this fault is slightly unusual, and the reason for that is if we just go back now to the power supply section, you can see here that it's also measuring from a detection point of view. So if you had a loss of the plus or the minus 15 volt supply, what would normally trigger is the microprocessor would put the amplifier into protection mode, and you would observe that from the front fascia. Here that was not the case, so it was enough that the 3 volts was enough to just keep it out of the protection mode. And of course this loss of voltage or effectively loss of supply to the input selection IC resulted in the IC incorrectly operating. So i.e. sometimes it would power up correctly, sometimes it wouldn't. So that's when you had the loss of audio. But to all intents and purposes the amplifier looked like it had powered up fine, and the speaker protection relays changed over if you selected from the fascia. So a little bit misleading. And then the other point was that you would have this sort of crosstalk issue because the IC is not functioning correctly. So it's kind of an interesting fault, I would say. Like normally when these voltage regulators do fail, this is probably the first one that I've seen where it goes to about 3 volts. Normally they're sort of 0 volts or just a couple of millivolts, and they are running very warm. So I would imagine that there is some form of short circuit inside of there. So once the amplifier was reassembled, then of course you're in that test phase mode, and when I applied different input signals, then the input selection was absolutely perfect, no issue, no bleed through from any channels at all. So the next part is then to move on to the adjustment. Now the adjustment on this amplifier is twofold. You have a DC offset adjustment, and you also have a bias adjustment as well. And the bias adjustment on this amplifier, as with all of these series of amplifiers, when you get them in the workshop and you do the initial measurement, it's always very high. And that's what I show here in the video. What you can see is that when the multimeter is connected and then we then measure across the test connectors, and I'll show you that in a moment from an extract of the service manual, you can see here that the bias millivoltage across the emitter resistors on the test connector should be 20 millivolts plus or minus 0.5 millivolts. But it's up here at 33.56, and this is for the left channel, and it was about the same value for the right channel. And that is overdriving the output transistors with no signal connected at all. Now, when I'm doing the repair, I power up the amplifier via the Dimball tester. And what I do is I just do the initial adjustment. And I've mentioned this before. Because this amplifier mainboard is very dusty, I depower the amplifier and I will spray directly into the bias potentiometers and also the DC offset potentiometers, deoxit, and I'll just rotate them backwards and forwards and move them back to approximately their original position. And the reason why I'm doing that is just to clean off the carbon track, make sure there's no dust or dirt, and then when you come to do the adjustment, it should be very, very smooth to make the small amounts of change. So once they were clean, power the amplifier back up again, and what I do is I just set the bias resist or the bias output setting slightly low, so it's about 18 millivolts via the dim bulb tester, and I will leave the amplifier running in a stable environment, so no drafts, and about 30 minutes later I'll come back then to make the adjustment. And as I'm showing you, the bias adjustment is then set to 20 millivolts, and what I've made up, and I have these in different orientations in the workshop, is just a small little test connector, so I can plug it directly into the socket, and you're not there trying to balance multimeter leads, and potentially you might get an incorrect measurement because the lead is not making correct contact with the circuit board. And then once the adjustment is made, both for the left and then for the right channel, what I'm now showing you is the extract then from the service manual. So what you can see here is the left channel, but what you're doing here would be exactly the same also for the right. What you see on the board are these test connectors, and then you have the preset that we mentioned a moment ago, and the bias here or preset is V001 for your left channel and V6002 for your right channel. Now to set your DC offset, that again is very easy, and the DC offset for this amplifier was probably about 22 millivolts, so that's actually outside specification. But for anyone who's listening or undertaking repairs, don't be concerned if it's like sort of 20 odd millivolts, right? That is perfectly within the normal adjustable range. And also as well, components will drift over time, so expect that if this amplifier has been in operation now for a number of years, part of the repair and service work will require this adjustment back to factory, what I would say adjustment values. So you just connect your meter onto the rear output terminals, as I said, for the left speaker in my example, and then what I then do is I will then adjust V6003, and again on the photograph that I'm showing now, you can see that I've drawn a circle around both the bias trimmers and then also the DC offset trimmers and also the test connectors as well. So you adjust it to as close as you can to 0 millivolts, but you have some margin of error. So margin of error here is about plus or minus 3 millivolts. So once you do the adjustment, just wait and just get stabilization, and it will fluctuate slightly but not too much, and then you can just do maybe the other channel, then come back until you feel comfortable to say that's as good as I can possibly get it, it's within specification then, and then that is the setup and alignment done. What I also show as well in the video, just as a matter of fact, is the underneath of the circuit board. So this is the main amp board, and the reason why I do that is remember that there are components on here like the voltage regulators, and these power components sometimes can emit heat, and that results in some cracking around the pins of the voltage regulators. Because we repaired them, we weren't looking for dry joints, but the board is still examined for that. Any mass production type piece of electronics, sometimes you can get bad solder joints, and that's the bit that you've got to just make sure there's no sort of issue. So there was maybe a couple of them not causing issues, but a bit like a bad tooth, you didn't want to sort of wait for an issue to happen, so we just reflow those connections then. So the other thing that was also done as well was just the cleaning of the user controls. So this is both the volume control and also your bass, treble and balance control potentiometers. And also as well, a check was made on the encoder, which is the input selection encoder. From an operational point of view, there was no issues detected. On some amplifiers, what you can find is the original lubricating grease can dry out, and you may experience random switching. That's common, so you would need to remove the encoder, just take it apart, clean off the original lubricating grease, make sure the contacts are then clean, and then you could then apply, for example, some deoxit grease just to put back on the longevity then. So once all of that work was complete, we have to then look at what the third issue was, which was this auto standby mode. Now, I've seen this many times on these series of amplifiers, and it's as if sometimes the microprocessor just gets messed up. Alright, so the way in which you would turn off the auto standby mode is you power up the amplifier, and then you will keep your finger pressed on the source direct button and keep it pressed for longer than 5 seconds, and what you'll find is that the power LED will flash once, and that means that the standby mode has now been turned off. And then if you want to then turn it back on, as we did in this case because we need to test it, again, source direct button, keep it pressed, and then what you'll find is that the power LED will then flash 3 times, and then that tells you that the auto standby mode has been re-engaged or reinitialized. And then all that I do is I don't touch the fascia or the remote control, nothing. I don't have any input signal source connected, the speakers are still connected, and I just leave it running. And I was monitoring the amplifier, and bang on 30 minutes later you saw the amplifier then switch into standby mode. And what I'm showing here in the photograph is just that the power LED indicating it's static red to show that it's in standby mode. And you could get it out of standby mode by the remote or by rotating, for example, the input selection, and then what you'll see is that it will then initialize the amplifier, and then after about 5 seconds, if they're selected, you should hear either speaker set A or speaker set B relays, protection relays, change over them. So that really brings us to the end of this repair tutorial. So as I said earlier, it was interesting to see this failure of the voltage regulator and the issue that it sort of caused and manifested itself without the amplifier going into protection mode. So as always, I appreciate you stopping by, and if you need any help or support or guidance or more information, by all means drop an email through to audioamplifierservicing@aol.com, and I'll be more than happy to help and provide any guidance or support that you may require. So until the next time, all the very best, cheers, and bye bye.